Welcome back, friends. This session is our second session on Java learning process. With this session, I will complete all the theoretical work, all the theoretical explanations will be over in this session. Next session onwards, we will go ahead with learning practical stuff. I'll start typing code in the next session, is what I mean to say. So let's proceed about the architectural details of Java. Java is actually composed of three different blocks, I can say. Three different components are there in any Java code or any Java related stuff that we are looking into. So I see it as Java programming construct, Java bytecode, and Java virtual machine. So what is that? We need to understand that quickly. Java programming constructs are nothing but they are the code that you are writing. The code that you write is all object oriented, and the code that you write does not have any sort of platform dependencies. This is one of the features that I told you some time back, followed by robustness. The code, whatever we are writing, is completely robust. So this is programming construct. Whatever code you are writing is what I am referring to as Java programming construct. Second component is Java bytecode. What do you mean by that? The code that you have written is to be converted to a class file, and the class file is so versatile that you can write it once, generate the class file once, and run it anywhere. Any platform you can run it. There is no platform dependency whatsoever is connected to it. So it is pretty easy for us to run it anywhere. So this is Java bytecode. And then Java virtual machine, it's platform dependent. There will be a Java virtual machine for Windows. There will be a Java virtual machine for Linux platform. There will be a Java virtual machine for maybe Mac. So now the process is pretty simple. When I send the source code, that is the code that I have written, it will go into the JavaC compiler, and then this compiler will generate the bytecode, which is called as the class file. And the class file is platform independent, which means I can run this code in any platform I can use this class in any platform without any problem. But after this, it has to go to a Java virtual machine, where you can see that in this diagram, JVM for Windows is specifically available, JVM for Linux is specifically available, JVM for Mac is specifically available, and they are platform dependent. So the code goes into the compiler generates the class file goes into the JVM. Up to the class file generation, it's all very simple, and after that we need some platform dependency in the form of JVM. So now the next step is to understand how exactly the JVM works. That's what I'm going to teach you right now. That's what I'm going to discuss with you right now. We will see that through a diagrammatic representation, which will as well be very comfortable. I'm going to see that. We are going to explain about that. Now, when you see that any process, any compiler, be it a C compiler, be it a C++ compiler, any compiler, it will have three steps involved naturally in any code running or code execution. That is nothing but linking, loading, initialization, and finally execution. So loading is the process where we initiate stuff, and in linking we link all the object files together. I have shown a demo in my some of the videos in the previous lectures, where I have also shown how to link and load the files for C programming into GCC compiler. So we have shown that, and then here it is no different. What will happen here? Here we have three different areas again. I split the Java virtual machine into three different areas. The first area is pretty simple, where it is class loader subsystem, it is named as. Second area is runtime data area. The third area is nothing but execution engine. There it goes completely with execution. Now what is the first area all about? It is nothing but the loader. So what will happen here? The class loader will read the .class file, which means the input that is generated in the previous step. You can see that here we have the class file generated here, and that will be in the form of .class file. So this input is now sent into this class loader subsystem. So this class loader reads the .class file. It will now read it, and then the corresponding binary data will be generated. First step is that the corresponding binary data will be generated, and it will be saved into the corresponding method area. Now, what do you mean by method area? Don't worry about all these right now. The method area is here, so I will tell you what it is when I come there. So the code, the binary equivalent for this will be generated by this dabba, and then it is then sent to the corresponding method area, is what you need to understand. So the information, there are certain information that we need to store for each .class file. What are the information that we are storing in the method area is simple. First one, the name of the class loader and immediate parent class. These details will be available. What do you mean by that? The class, the name of the class loaded, and then immediate parent class, if any, will be stored. Second, whether the dot class file is related to any other class or an interface or an enum, this detail will be stored. Don't worry about all this now. I'm just giving you as an information. This could be needed sometime later. Third, what are all the modifiers, variables and method information that are available in it. So this entire dabba will help you in simply collecting this information and then help you go ahead further. Now the next step is linking. What do you mean by the linking? In this linking step, we perform the verification. You can see that we perform the verification and then preparation, and sometimes resolution is a term that we use as well. So what is verification? The verification process is the one which will ensure the validity or the correctness of the dot class file. It will check if things are proper. So if there is something wrong, we will get a error or an exception. We need to call it as in Java. It is not an error, it is error in C. Now we call it an exception here. In case this bytecode verifier finds out any error, there will be an exception thrown. And what is preparation? Preparation is the second step that we need to go for. JVM now will allocate memory for the class variables. So we need to allocate memory, right? Whenever we are running a code, there will be variables, there will be stuff there, so which we need to allocate memory. So that's the second step. Now the linking is all about verification, preparation and resolution, where symbolic references will be replaced with the direct references. We need not worry about this much right now. We can go deeper into it sometime later. Just understand that the first process is loading, where we collect information. We make sure that we generate the generated dot class file is converted to a binary file. All those processes happen there in class loader. Then it is all about linking. The linking will make sure that everything whatever we have done is correct. Verification is all done. That's what is done. And then finally we come with the process of initialization. What do you mean by initialization? Initialization, we all know that what will happen in initialization. We will have to initialize the variables with appropriate value. What do you mean by that? The static variables are assigned with their values, that's all. Whatever variables we have declared, the variables will be assigned with the corresponding values. So these three are the process that are done: linking, loading and initialization. Linking is explained, loading will verify, prepare, and then initialization will initialize the value. That's it. And then the next area of discussion is nothing but memory, runtime data access, which will talk about all the memory components. I'm going to talk about it right now. So we will see that, and it's coming to the next data, where runtime data areas. We have 5 different memory sectors there, memory areas there: method area, heap, stack area, PC register, and native method stacks. So when you go to method area, in this method area, all the class information, it will be like class name, parent class name, variable information, etc. are stored. Heap area is the one where information about all the objects are stored, and one should also remember that there will be one heap area per JVM, which means each JVM will have one heap area only. Now stack area. What is stack? Stack is all about storing the temporary data variables. Just like in any other programming language, here also we have stack area, and that is all similar. So stack's purpose is no different. PC register. What is PC register? PC register is nothing but it is program counter register, where we will store the address of the next subsequent instruction to be executed. Native method stacks is the one where for each and every thread separate native stack will be created, and it will store the native thread information. That's all. So when you have a code, all these kind of splits up are done, and that will help you to store the information appropriately. And coming to the execution engine, we will see more about the execution engine, where the complete execution happens. It will pull in the corresponding native method library, it will take care of the interface, and that's how the JVM works. Don't worry much about execution engine now. We can show some examples in the future. Now you understand that it has got 3 different sectors. One is class loader subsystem, second one is runtime data areas, third time is execution engine. That's all. So we have seen the architecture today. This is the overall architecture. The code is converted, the code is sent into the Java C compiler, then the bytecode is generated, and from there you get into the corresponding JVM. The JVM will now help you in getting the execution done through this 3 steps. This is what I have explained you in my complete lecture. I hope you guys understood it, and we will see about the rest of the things with a simple example, maybe hello world, in the next class. Thank you very much. Thanks for following me out.